mirror. Okay, you have a concave mirror. Okay, and the focal length of this mirror is given, that is minus 20 centimeter. And suppose this is the principal axis. Okay, now a point object is kept at a distance of 30 centimeter from pole. Okay, at a distance of 30 centimeter from pole. Okay, and this point object is actually oscillating. This point object is actually oscillating with amplitude of oscillation that is given 2 millimeter. Okay, so capital A is the amplitude of oscillation. Okay, so what is the question? You have to calculate the amplitude of oscillation of the image. Okay, that you have to calculate. Okay, and that 30 centimeter distance from pole to object, that is actually this position. The distance is actually from pole to the mean position of this object. So this is the mean position. Okay, so this object is oscillating like that, and the amplitude is given. Okay, so how will solve this? So to solve this, we'll use this formula. We know for spherical mirror that 1 by V plus 1 by U, that is nothing but 1 by F. Okay, so now the distance from pole to this point object is how much? That is 30 centimeter. But you see that positive direction is actually what? This is the direction of incident ray, right? For concave mirror. So this is the direction of, or you can say this is the positive direction. But when you are calculating that distance of object from pole, so always you have to calculate the distance from pole. So this direction actually what? This is the anti-parallel to positive direction. So you have to keep, U is how much? कितना हो जाएगा अंजू बताओ?
-30.
Exactly.
-30.
It should be -30. So from here I'll get the value of V. So position of image from pole, that I can write. So it should be how much? It should be -30. Then you have focal length is how much? That is -20. Okay, so it means that V will be, or 1 by V, that should be equals to how much? That should be 1 by 30 minus 1 by 20. Right? So it means how much you'll get actually? So it will be basically minus 10 by 600. And on 0 will be cancelled. You will get that position of image from pole, that will be nothing but minus 60 centimeter. Okay. Position of image, that will be minus 60 centimeter. So we what type of image it will be actually? So you see that U is actually negative sign and V is also negative sign. So for spherical mirror, when U and V both have same sign, then it will be actually what? It will be real image. Please note that when U and V have same sign, for spherical mirror, the image will be real. But if U and V both are in opposite sign, for mirror, that image will be actually virtual image. Okay, so actually that position of image is somewhere here, right? This is the position of image. Why? Because this is negative, so distance will be from pole to this image, that is actually 60 centimeter, right? So that V I have obtained, but our job is to calculate that amplitude of oscillation of image. So how will calculate? Again, I will use this formula. Now from this formula, small differentiation of this equation can give you minus 1 by V square del V minus 1 by U square del U. And since focal length is always constant for mirror, so I can write that small differentiation of 1 by A, it will be 0. So from here I'll get the deviation of mirror, image position, that will be nothing but minus V square by U square into day. Okay. So it means we know that value of V and U, that is minus 60 as well as minus 30, right? So V is minus 60, U is minus 30 square. Now, from this calculation, from this formula itself, I can calculate the amplitude of image. So when that your point object is at mean position, when it is going to extreme position, that change in U, that will be how much? Change in U will be how much? Can you please tell me? Anyone, Anju? Suppose your point object is at mean position. Now, when it is going from mean position to extreme position, how much is the change in U? That will be nothing but same as amplitude of oscillation, or you can say that will be minus 2 millimeter. Minus 2 millimeter, right? Am I correct? Is this okay?
Sir, can you repeat that?
What I'm saying, so distance always measured from pole, right? Pole to mean position. I mean that distance is given. When that particle is at mean position, distance from pole to that mean position, that is 30 centimeter. Now this point object is actually oscillating. So when it is going from mean position to that extreme position, so there is a change in position, right? Or there is a change in U, because आपका U कितना है? Distance from pole to point object. अब point object यहाँ से जब यहाँ चला गया तो इसका change in U आ गया ना? U का change कितना आया है? When this point object is going from mean position to extreme,
30 minus 2.
that change is just nothing but this distance. भाई पहले आपका U कितना था? ये वाला था. अब U कितना है? ये वाला हो गया. तो change in U is how much? This distance, right?
Yes, sir, yes.
Change in U will be how much? So initially your point object is here. So U will be this much. Now when it is going to extreme position, U will be this distance. So change in U is how much? That is this. And
Yes,
that will
sir.
be actually hot. That is actually negative. Right? So यहाँ पे कितना था आपका? 30 था, वहां से 2 मिलीमीटर कम हो गया. So that will be actually negative, right? Because ये वाला आपका बड़ा है ना? ये वाला छोटा है ना? तो फाइनल माइनस इनिशियल करोगे, so you'll get minus 2. So it means dV, or this is actually, dV is actually representing that amplitude of oscillation of image. That should be equal to how much? So you have 2 into 4. So that will be 8 millimeter. Okay, so this is actually 8 millimeter is actually amplitude of oscillation of your image. So from here, what I can say, that when your point object is going from this mean position towards mirror, when point object is going from mean position towards mirror, your image is actually going from mean position to away from the mirror, right? Because du was actually minus 2, but dv you are getting plus 8. So there is a change in sign, right? So they are actually opposite in sign. When that particle is going from mean position towards mirror, your image is actually going from mean position away from the mirror. Is this clear to all what I'm saying? क्या इतना clear है? If you have doubt, please ask me. शेखर?
सर डीवी हमारा एम्पलीट्यूड है.
हाँ, dv is actually amplitude. Because जब आपका ये चेंज हुआ है ना, पार्टिकल यहाँ से यहाँ गया है, that time image will go from mean position to extreme position, because this is the maximum change in du here, representing that minus 2. That is the maximum change in u, and that for corresponding maximum change in image you can calculate, है ना? Because there is a linear relationship. So जब आपका maximum change in du है, that is nothing but amplitude of oscillation of your point object. At this time, it will give you that maximum amplitude of oscillation of image, because you can clearly see they are actually linearly, their relation is actually linear. Okay, ठीक है ना?
Yes, sir.
Yes, sir.
Okay. Now, suppose you have again, you have a spherical mirror, and this time that mirror again concave. Problem number 2, you have a concave mirror. Okay. And again, focal length is minus 20 centimeter. Focal length is how much? Minus 20 centimeter. So let us assume this is the principal axis of your mirror. Okay. And a point object is kept 30 centimeter away from pole. So this distance is actually how much? From this point to position of point object is 30 centimeter. Okay. And initially at time t equals to 0, this point object is actually where it is on the principal axis. But with time, this point object is actually moving upwards. With speed also given. That speed of motion in the upwards that is given as 2 centimeter per second. 2 centimeter per second पे क्या है? This point object is moving upwards. So what you have to calculate? You have to calculate the velocity of image. कितना है? So velocity of object is actually how much? कितना given है? शेखर कितना given है? सौरदीप
minus 30 centimeter.
नहीं, velocity of your point object that is given 2
2
centimeter per second.
centimeter.
And distance of this point object from pole to this point object that is 30 centimeter.
Minus 30 centimeter.
Minus 30 exactly. Okay. So how will calculate? So before to calculate this velocity of image, first we have to calculate. What you have to calculate? The position of image, where it is actually. Okay. So if you see that data is actually same. From if you see that initial problem, in problem number 1, we have used this data, right? Focal length was 20 centimeter and distance of point object from pole, it was 30 centimeter. And we have obtained by using this formula 1 by v plus 1 by u equals to 1 by f. By using this formula, we have obtained the position of image. That was how much? Minus 60 centimeter, right? Am I correct?
Yes, sir.
Yes, sir.
Okay. Now, if you remember, we have discussed that magnification of spherical mirror that is represented as how what? That is nothing but height of image divided by height of object. And that can further be written as minus position of image to that of position of object. I can write, right? So if you remember, initially in previous class, we have discussed this formula. If you remember, the velocity of image minus velocity of object, velocity of mirror, right? And that is nothing but minus v square by u square into the velocity of object minus velocity of mirror. We have used this formula, right? If you remember, am I correct?
Yes.
When I'll use, again, we have to calculate that velocity of image, but we are not using this formula. Why? Because this formula will be applicable when your point object is moving perpendicular to the surface of your mirror. When this point object is moving perpendicular to the surface of your mirror. But this time, this formula cannot be applicable because this time that point object is actually moving parallel to the surface of your mirror. So you have to calculate the velocity of image. Basically, you have to use this formula. So I'll use this formula to calculate that velocity of image. So from this formula, what I can write that hi divided by ho, that is nothing but minus v by u. And if I write further, what I can write from here, I can write that hiu plus hov, that should be equals to 0. That should be equals to 0. Okay. So now if I differentiate both side with respect to time, if I differentiate both side with respect to time, then what I'll get? What I'll get? So first term, if you tell me, if you see, I can write hi du by dt. Okay. Then further, so I'm differentiating this equation. Okay. Second term, you will get u into dhi by dt. Right. Then from this term, what I'll get, I'll keep v as a constant and I'll differentiate HO with respect to time. Then we have last term also, that will be what? That will be, I have to keep HO as a constant and I have to differentiate V with respect to time. And that should be equals to how much? That should be equals to 0. Now, can you please tell me what will be the value of this factor? And also what will be the value of this factor? This is actually why, what? U is actually what? This is actually this distance, right? The distance of object from pole, right? When this particle is moving upward, there is no change in actually U. U का कोई change नहीं होगा. If you see, when that particle is moving upward, there should not be change in U, because distance of object from pole, it will always be what? It will be same. U cannot be changed. U cannot be changed. So if U cannot be changed, V cannot be changed, because we know this formula. We know 1 by V plus 1 by U, that is nothing but 1 by F. So F is constant. If there is no change in V, sorry, there is no change in U, definitely there will not be change in V. So it means that when that particle is moving upward, there will not be change in U. So this term will be 0. So of course, this term will again be 0. So you have only these two terms. Okay, so what I can write from here, U dHi by dt plus V del HO by del T, that should be equal to how much? 0. So this actually dHi by dt, what is this actually? dHi by dt, it represents that change in height, image of height with respect to time, change in image height with respect to time. So that is actually your velocity of image. dHi by dt, that should be equals to how much? Minus V by U into del HO by del T. So this is actually your what? Velocity of object. Velocity of object, and dHi by dt, that is the velocity of image. So I can calculate this. So we know minus V is how much? That is minus 60. U is how much? That is minus 30. And del HO by del T, that is given how much? That is 2. Okay. So if you calculate, you will basically get minus 4 centimeter per second. So what is the meaning of minus? So you have this side, you have a image. When that object is moving upward with speed 2 centimeters per second, your image is actually moving downwards with speed 4 centimeter per second. Speed 4 centimeter per second. Is this part clear? Can you please check? Can you please check?
Yes, sir.
Okay. Now we have a next topic of spherical mirror, and that is basically what? Refraction from let us discuss first for refraction from plane mirror, plane surface or mirror, whatever it is. Okay. Okay, sorry. So suppose you have a two medium and they are separated by an interface. Okay, let us assume this is the medium on. Okay, the refractive index of this medium is given N1, and this is the medium 2. Refractive index of this medium is given N2, and these two mediums are basically separated by by this interface. Okay, and let us assume this is the normal. This is the normal. Now a ray is incident. Okay, a ray is incident on this interface at an angle of I. Okay, then some of the portion of this ray, what will happen? Some of the portion will be reflected and some of the portion will be refracted as well. And this angle is actually what? This is the angle of refraction. The angle between vertical line and refracted ray, this is actually what? This will be the angle of refraction. Now, this angle of refraction can be smaller than I. When angle of refraction will be smaller than I, angle of incident, कब होगा? जब आपका ये medium 2, when that medium 2 will be denser, right? This R will be, angle will be smaller than angle, or you can write angle R will be smaller than I. When this medium 2 is denser, N2 is denser, right? ठीक है ना? And that angle of refraction will be greater than angle of incident. कब? जब आपका, or you can say here, कब होगा ये आपका? जब N2 greater than N1 है. And this will be happen when N2 is smaller than N1, right? But before going to discuss that Snell's law, one thing you have to keep in mind, that whenever that light is coming from medium 1 to medium 2, on property or on thing that will never be changed. What is that actually? That is actually frequency, right? When that light is coming from one medium to another medium, so light is composed of photons, okay, and each photon is having some frequency, right? Or light is actually electromagnetic wave, it has some frequency. So when light is coming from one medium to another medium, frequency will never be changed, and frequency can be written as nu, and that is actually what? For medium on, what I can write? That medium on, velocity of electromagnetic ray in medium on divided by what? Wavelength of light in medium on. And this can further be written as, because nu is not changing, so nu will be same for medium 1 as well as medium 2. So for medium 2, what I can write? That nu is nothing but velocity of electromagnetic wave in medium 2 divided by wavelength of light in medium 2. And we know V is nothing but what actually? Speed of light in air divided by refractive index of medium. So here from this equation, I'll use this equation. So basically, in place of V1, what I'll write C divided by N on lambda on. That should be equal to how much? From this expression, I can write that velocity of light or electromagnetic wave in medium 2. And that can be written as C by N2 into lambda 2. Okay. Here it will be lambda 1. So C will be cancelled, and I'll get the expression for lambda 2. And that will be nothing but N1 by N2 lambda 1. N1 by N2 lambda 1. ठीक है? So from that expression, what I can say, जब आपका light rarer से denser में आएगा, तो wavelength बढ़ेगा या घटेगा? Anju, can you please tell me? Dhruvi, Sorodip, when light coming from rarer medium to denser medium, what will happen to wavelength? Will it be larger or smaller? Will it be larger or smaller? Shekhar?
Larger,
Yes,
sir.
Chandu.
Huh?
Larger, sir.
Why? You got
No
this
change, sir.
you got this derivation, right? How I have derived that part. Did you get?
Yes,
So
sir.
you see, lambda 2 actually what? This is the wavelength of electromagnetic wave for medium 2. And that is nothing but N1 by N2 into lambda 1. Lambda 1 is actually what? Wavelength of electromagnetic wave in medium 1. So this is actually related to what? Refractive index. अब जैसे आपका medium 2 में आ गया है ना, अगर medium 2 denser है, obviously N2 will be greater than N1. If N2 is greater than N1, then what I can say? That this factor will be smaller than 1. This factor will be smaller than 1. What I can say? When N2 is greater than N1, lambda 2 by lambda 1, that should be smaller than 1. Right? It means lambda 1 greater than lambda 2. तो जब आपका light rarer से denser में आते हैं, basically what will happen? The wavelength will be decreased, and they are related by this factor. Please keep in mind. They are related by this factor. Same thing we have discussed when we have discussed about that young double slit interference pattern, right? We have discussed something, right? Is it clear what I'm saying?
Yes, sir.
Yeah. Sorodip, Dhruvi, सब बताओ.
Yes, sir.
Is this clear?
Yes, sir.
Okay. Now we will use Snell's law. So what I from if you remember that diagram, let us draw a rough diagram again. So you have a, this is the interface, this is the normal, this is medium 1 with refractive index n on, this is medium 2 with refractive index n2, and this was your what? This was your ray, right? So this is the angle of incident, and this is actually angle of refraction. So now if I apply that Snell's law, then what I can write? Snell's law of refraction, I can write that n on sine I, that should be equal to how much? N2 sine of r. Right? I can write. And from here I can write that sine I by sine r, that should be equal to how much? N2 by n1. N2 by n1. Now, can I write in place of n2, can I write c by v2? Can I write? Because if you remember that v2 is nothing but velocity of light in medium 2, and that is nothing but speed of light in vacuum divided by refractive index of this medium, of medium 2, and that is nothing but n2. So in place of n2, what I can write? C divided by v2. And again, in place of n1, what I can write? C by v1. And the c will be cancelled, and you will actually get v1 by v2. You will actually get v1 by v2. So it means I got sine I by sine r, sorry, and that should be equal to how much? v1 by v2. And v is nothing but f into lambda, right? F into lambda, where f is the frequency of oscillation, lambda is the wavelength. So from v1, what I can write? F into lambda 1. And again for v2, what I can write? F into lambda 2. Why I am writing f? Because frequency cannot be changed. That is independent on medium. So it means I can write this ratio sine I by sine r. That ratio I can write in terms of lambda and lambda, in terms of lambda. So sine I by sine r, that is nothing but lambda 1 by lambda 2. And you know what is lambda 1 and what is lambda 2. What is lambda 1, Anju? What is lambda 1? Can you hear me? What is lambda
Hello.
1?
Yes, sir.
What is lambda 1?
Wavelength in first medium.
Exactly. So lambda 1 is actually wavelength of this light in medium 1, and lambda 2 is wavelength of light in medium 2. Okay. Now, based on this refraction, there is a concept that is known as critical angle. There is a concept known as critical angle. Okay. So suppose you have a two medium 1, refractive index n on, medium 2, this is n on, medium 2, refractive index n2. And let us assume this is the interface. Let us assume this is the interface. Now, let us assume that medium 2 is denser and medium 1 is rarer. Okay. So what I can write? For denser medium, refractive index will be greater than the rarer medium. Now, this concept of critical angle is fully based on when light passes through from denser medium to a rarer medium. So when that light passes through denser medium to rarer medium, what will happen? The angle of refraction will be kya hoga? Angle of refraction, it will be greater than angle of incident, right? When light passes through passes from denser medium to rarer medium, what will happen? The angle of refraction will be greater than the angle of incident. Am I correct? Did you get what I'm saying?
Yes, sir.
So, but at particular angle, at a particular angle, what will happen? At a particular angle known as critical angle, the angle of refraction will be 90. So it means that refracted ray will pass like this. है ना? जैसे जैसे आपका एंगल ऑफ इंसिडेंट बढ़ाते जाओगे, एंगल ऑफ रिफ्रैक्शन भी बढ़ेगा अकॉर्डिंग टू स्नेल्स लॉ. अकॉर्डिंग टू स्नेल्स लॉ, जैसे जैसे आप एंगल ऑफ इंसिडेंट बढ़ाते जाओगे, एंगल ऑफ रिफ्रैक्शन भी बढ़ेगा. At a particular angle of incident, what will happen? That angle of refraction will become 90 degree, and this is only possible when that light is passing from denser medium to rarer medium. Okay, so this angle of incident at which refracted angle becomes 90 degrees, this angle is known as critical angle. This angle is known as critical angle. ठीक है ना? So from Snell's law again I can write that n2 sin theta c, that should be equals to how much, Shekhar? n2 sin theta c, that should be equals to how much? That should be equals to n on into sine of how much? 90 degree. Is this okay? So it means the expression for critical angle sin theta c, that should be equals to how much? N1 by n2. It means I can calculate that critical angle theta c, and that is nothing but sine inverse n1 by n2. And if you remember, we have discussed about that Brewster angle during that polarization discussion. If you remember, tan theta b was how much? Anyone? Tan theta b कितना थे आपके पास? शेखर, ध्रुवी, सौरदीप, कितना था? If you remember, that tan theta b was nothing but n2 by n1. But theta b is basically what? This is Brewster angle, right? Okay. So this is the expression for critical angle, and this is the expression for Brewster angle. So why I am writing this Brewster angle here? Because we already have discussed this Brewster angle in polarization. Then why I am discussing here? Because they will give you that problem based on these two formula. So they are basically correlated. How they will give you problem? Let us solve a good problem. Okay. So this time there is a problem. So that problem was, they have given that, so this is basically IIT-JAM 2022. Okay. So what was the problem actually? They have given the critical angle, that value they have given, and that was actually how much? 30 degree. And the question was very simple. You have to calculate that Brewster angle. That was the question. So simple question. Okay. So from this critical angle, I can calculate that ratio of n1 and n2, right? So we know this formula. Sin theta c, that is nothing but, just we have derived, that is nothing but n1 by n2. Okay. And we know that tan theta b, that is nothing but n2 by n1. So if I can calculate this ratio n2 by n1, I can calculate that theta b. Okay. So from this expression, I will calculate that n2 by n1 to calculate that theta b. So what I'll do, just I'll substitute this value. So sine of 30 degree, that should be equal to how much? N1 by n2. And we know sine 30 is how much? That is nothing but 1 by 2, and that should be equal to n1 by n2. It means n2 by n2 by n1, that should be equal to how much? 2. So just I'll substitute this ratio here, and I'll get tan theta b, and this will be nothing but 2, right? It means theta b or Brewster angle, that should be equals to tan inverse 2, right? And if you calculate, you will get approximately 63 degree. Approximately 63 degree. Okay. So you can imagine how much simple question it was. Okay. And that asked recently in 2022. Okay.
सर 70 डिग्री आ रहा है.
70 डिग्री आ रहा है, चेक करो जरा। tan इनवर्स 2 कितना आ रहा है?
70 degree.
इज दिस, कैन एनीवन वेरीफाई कितना आ रहा है?
17.48.
17।
Yes, sir. 70.48.
हाँ, बाकी चेक करो जरा, मैंने लिख के तो नहीं लाया, एक बार चेक करो। यू मे बी करेक्ट, लेट मी चेक।
सर 63 है, वो गलती से उन्होंने रेडियन में कर लिया होगा।
Oh, maybe. Okay, so you have to convert into degree as well. Okay. So
Okay,
you have
sir.
to keep in mind. Okay, whenever you are getting radian, you have to convert into degree. Okay, please keep in mind. Okay, so it's a very simple question. You will get 63 degrees. Okay, approximately. Now, second times that I'll not solve fully, but I'll give you hints. And that was a very good question actually. Okay, and this question is basically from IIT-JAM. IIT-JAM 2021. Okay, let me give you data. So there is a cross-sectional view of your cylinder. This is the cross-sectional view of cylinder, and the diameter of this cylinder is given. Diameter, it was 2.2 meter. Okay, the lower portion, half of the lower portion is basically filled by what? Water. Okay, na? And the upper portion is actually filled by what? Gas. Water का refractive index given था, and that is actually they have given 1.33. Okay. And there is a laser source on the lowest point of the surface of the cylinder. Here they have used a laser source. Okay, and that is actually where? At the lowest point of surface of the cylinder. And this laser source can be moved on the surface of the cylinder. This this laser source can be moved on the surface of this cylinder. Okay, and they have given this laser source actually pointing where? At the center of your cylinder. Okay, now when this laser source is moving away from the lowest point at a distance of 1.09 meter, then what is happening? Whatever ray is incidenting or whatever ray is striking the center, that ray is actually not going to gas. This ray is not going to gas. Again, I am repeating, you have a cross-sectional view of your cylinder, diameter is given 2.2 meter, half of the portion, I mean lowest half portion is filled by water, refractive index 1.33, and upper half is filled by gas. Okay, but they didn't give you that refractive index of this gas. A laser source is kept at lowest point, and the light from this laser source is actually striking at the center. And this laser source can move on the surface of this cylinder. When it moves at a distance of 1.09 meter from lowest point to this point, okay, from lowest point to this point, and that distance they have given 1.09 meter. This time, this laser beam, whatever this laser beam is striking the center, this laser beam cannot enter to the gas, medium. So from this expression, you have to calculate what? You have to calculate that refractive index of gas, you have to calculate. Okay, critical angle you have to calculate. Also, you have to calculate the time taken by laser beam to come back again to the surface. Time taken by laser beam to come back again to the surface of this cylinder. तो क्या हो रहा है आपको पता है phenomena? ये जा रहा है, strike कर रहा है ना, and this they are basically two medium. Whatever ray will be going, they can be completely reflected and reach the surface, or they can be completely refracted and they can be reach this surface. So time taken by this ray or this beam to reach the surface when s greater than 1.09 meter, at this time how much time it will take to reach the surface? or when S is less than 1.09 meter. So how much time it will take to reach this surface, है ना? So क्या हो रहा है actually? आपका ये हो रहा है जब आपका S equals to 1.09 मीटर में क्या हो रहा है actually?
सर वो क्रिटिकल एंगल पे है।
Exactly. So at critical angle क्या हो रहा है आपका? रे क्या हो रहा है? That cannot be entered to the second medium. Okay. So S greater than 1.09 मीटर में क्या होगा? अंजू बताओ। S greater than 1.09 मीटर में क्या होगा आपका? बताओ। There will be complete reflection, right?
Reflection, sir.
Complete reflection. Refraction नहीं होगा यहाँ पे, right? Because whenever angle of incident greater than the critical angle, okay, then what will happen? That full ray, whatever ray is incident, that will be completely reflected. There will not be any refraction. So it cannot enter to the second medium. Okay. So can you please calculate that what will be the theta c? Theta c कितना हो जाएगा? So let us assume this distance is how much? Here you have a source and this distance is how much? 1.09 meter. Okay. Now from diameter, I can calculate this radius. Radius will be how much? It will be 1.1 meter. ठीक है ना? Diameter is 2.2 meter. So radius obviously कितना हो जाएगा आपका? 1.1 meter हो जाएगा. ठीक है. Now to calculate that critical angle, what I'll use? I know that S equals to how much? This curvature can be written as R into theta. So it means theta c will be how much? That will be nothing but S by R. Okay. So if I give that S is how much? So S is nothing but 1.09 meter and R is nothing but 1.1 meter. Okay. So from here you will get some values. Okay. So if you will basically get in what? That theta c will get in radian. So to convert it into degree, what you have to do? You have to multiply by 180 by 5. Okay. So if you do it, basically you will get 55.77. ठीक है ना? So now you got theta c. Now how will calculate that refractive index of gas? So we know this formula, right? That sin theta c is basically nothing but what? क्या लिखते हैं हम? n1 by n2.
N1 by N2, sir.
यहाँ पे n1 कितना हो जाएगा आपका? n1 कितना हो जाएगा?
Refractive index of gas.
Exactly. Refractive index of gas divided by refractive index of water. Okay. So from here, that theta c is given and nw, this is given. That is how much? 1.33. So I can calculate that ng. Okay. Please do that calculation. So this is nothing but sin theta c. Theta c we have obtained, that value is 55.77. And you have nw, that is 1.33. Okay. So if you calculate this value, basically, okay, you will get that.
Sir, Alok sir is waiting for the class.
Okay. This time is over, right? Okay.
Yes.
So you should stop. Please do this homework. Okay. So what you have to calculate? You have to calculate that refractive index of gas from this equation. Also, you have to calculate the time taken by beam. How much time it will take to reach that surface? Okay. That refracted ray. So this distance will be how much? 2r by velocity of light. Okay. In different medium. Please do this calculation. Okay. Time taken when S is greater than 1.09 meter. How much time it will take? And when S is less than 1.09 meter. So at these two situation, how much time it will take to reach that surface? You have to calculate. Please do it. Okay. Okay. I'm leaving.